All right. Good evening, everybody. Welcome to the first of two August meetings that we have for you. And you have to excuse the little bit of our delay. We had an issue with our normal meeting space, so we had to move. And everybody's starting to come in and get some pizza and the whole thing. So without further ado, let's get rolling. So our usual agenda for those of you who may be here for the first time, we thank our sponsors, talk about what's new in the Java space. I'm going to introduce Dmitry Choiko, who's our guest speaker tonight. He'll give his main presentations, and then you have to deal with me again afterwards just to do our usual wrapping up of stuff. So our first sponsor is our silver sponsor, Azul. They make the downstream distribution. Zulu, unless there was a name change. Bellsoft has one too, so Bellsoft and Azul have their implementation of OpenJDK with Crack, and it's not what you're thinking of. It's coordinated restore at checkpoint. So if you want to experiment with that, you can. And then our partner is DevNexus, that awesome conference where a lot of us were represented back in April of this year and March 4th through 6th next year. The call for papers is open. So go to devnexus.com, I think it is. Our per-meeting sponsors are JetBrains and Eclipse Foundation and Jakarta EE. JetBrains, of course, they provide us licenses to IntelliJ IDEA for us to give away. It's good for 1 year. And then the Eclipse Foundation and Jakarta EE, they offer web hosting for Java user groups. Or it should be not web hosting, that's a conference hosting, so yeah. Memberships, we're part of the Jakarta EE ambassadors, the microprofile working group, the Jakarta EE working group, and the virtual jug. And who are these Jakarta EE ambassadors, you might be asking? We are an independent group, a grassroots group of people committed to moving Jakarta EE forward through active community participation and advocacy. And we do a lot of that here, all right? And I'm very, very happy that we are that involved and are that active in that. And you can go to the Jakarta EE ambassadors.io website for that. Okay, so what's new? There's a typo in there. It's actually release candidate 1 just last week on the 8th. 2 is going to be sometime next week, I believe. But this is Java 23 that's going to come out in the GA release on September 17th. That's the first half of the features that are will be part of JDK 23. This is the second half. Structured concurrency is going to be in its third preview. Everybody's kind of waiting for that to be final for more virtual threads, interoperability. So, and I kind of like this module import declarations where you can, in your Java docs, you can use Markdown. So that should be fun. I need to experiment with that. And Jakarta EE11 still not released yet. They're migrating from Ant to Maven, if I understand that correctly, for the TCK. So that's what I've read in Ivar's blog posts. So Milestone 4 was coming out. There might be a release candidate before the GA release. That all depends. And that's the first half of the specs that are updated. There are 16 out there out of the 30 that are part of the platform. And there are 42 specs altogether at my last count. Did I hit the? Yeah, those are the other ones right there. So, interestingly, Jakarta Validation and Jakarta RESTful Web Services now support Java records. All right. I mentioned last month that I use this random drawing application for choosing a winner, and I said you guys should actually see this. So I have it there available for you to, to clone the repository and play with it. And please, if you see something, that looks, hey, could be improved, by all means, do a pull request and we can, all work on it together. It's a standard, plain vanilla, yes. You know, Scott, you're more than welcome to, you know, take on that task. Well, I'm actually I'm proposing to put together a series of blogs on the microprofile specs. So anyway,
end up winning every month.
yeah. So, all right, so enough of me talking. I'm going to introduce Dmitry, who is just wrapping up the JVM Language Summit. That was the last day, right?
Yeah, correct.
Yes. And so Dmitry is a senior performance architect at Bellsoft, and also an Open JDK committer and a public speaker. Prior to joining Bellsoft, Dmitry worked on the Hotspot JVM at Oracle, and before that, he had many years of programming experience in Java. He is currently focused on optimizing Hotspot for x86 and ARM, previously being involved in rolling out JEP 386, which I forget what that is at the moment. It must be Hotspot related.
I'll find support.
I should know these by heart, shouldn't I? Which enables the creation of the smallest JDK containers. Yeah, that's project, not Layden. There's another one.
Portola.
What's that?
Portola.
Okay, that's right. So Dmitry continues his journey in Jersey. We're in Jersey in the containerization process, and is happy to share his insights and experience in this field. Dmitry is a well-known speaker in the Java community, and one of the recent public presentations is available at this website, which you can get on our website. And you're also a contributor to the D-Zone. We need to get you to write for InfoQ. So, and his most popular publications includes, and I have them listed on the website as well. And on a personal note, Dmitry, I know we had a big snafu last year in September. I had no idea you were going to be at the in New York at the 25th anniversary celebration of the JCP, right?
JCP.
Right. And so anyway, he was scheduled to be out, I guess, the day before that, and you know, so at any event, all of a sudden I see him at this event, and we're like, hey, wait a minute. So thanks for putting up with that, and for coming out here on a nice August day. So, all right.
I'll share the screen. Hello again. That's indeed me.
Bill, how are you?
We'll start with that part. All right.
Thank you.
That was a very interesting and mindset and introduction because it correlates with the contents of this talk. The idea was like, can I make a talk not just about Java, and a talk where we can share stories? I would like to share some of my personal stories. You can share yours about the technologies that go together hand by hand nowadays. We still apply them typically together in many projects. You implement some client-side things, and they're based in JavaScript, and obviously we love Java in many places, but nowadays it's quite typical to have them as a backend. And when I was at school, our math teacher performed a funny trick. She showed us a theorem and then said, okay, I finished the theorem, and now I actually say, which is true, this statement is wrong. So we have just proven it, and there is a mistake. So please find it. And I wonder what happens if someone adds an error or mistake into a project like random drawing application, and how soon that be noticed. How about, yeah, supply chain, open source, and all that. Anyway, let's start. Yes, I participate in OpenJDK project, and I love it. And there are always topics to discuss based on that. And the company I work at is called Bellsoft. You can find some stickers in that randomized heap over there. And we do release our own OpenJDK binary distribution called Liberica JDK. And also we realized that containers are extremely important and we need more fine-grained control over container security and functionality and all that. So we started to release our own Linux distribution called Alpaca. And besides OpenJDK, we provide native image experience there. So you can use so-called Liberica native image kit to create your native images from your Spring Boot or any kind of applications that support. And yeah, we participate in all such organizations like Cloud Native Computing Foundation. And you can get long-term supported builds, vanilla OpenJDK, specialized Fuse JDKs, or crack JDKs. And we do contribute our improvements or fixes back to the mainline and downstream and update releases as well. So what's about Java? My first language wasn't Java. Not sure about all of you, but I guess not as well. But surprisingly, any experience that we meet in our life helps us in future. Like, again, when I was at school, my first programming language was, who can guess? No, BASIC, yes. And my first job was actually in BASIC. At that time, they existed, such jobs. Yeah, and at that time, of course, I always knew Pascal and something else. But yeah, it started with a different language, not Java. And BASIC is quite different from that. That's more like C, right? We can write this program in Java, actually. We all know that now. That talk, that's slide deck is now not so challenging, right? This is Java we like. No classes. No main class. Well, it all started a long time ago. Both technologies started a long time ago. And last year, I was not far away from here in Philadelphia, and I saw Sylvester Stallone. Who would told me 30 years ago that I will see him in person? And the same happened to me this year, or last year too, as actually, but not in the same small space. To sit and discuss things with James Gosling, right? We can do it in our community, and that's a very important technologies that changed our lives. Yes, they both started at 1995. Some people still see no difference between them, and I think it's forever. Yes. Yes, and the funny part is that JavaScript trademark is owned by Oracle. Like, because you really can, have a mistake and say one instead of another. So from a trademark perspective, that's important. Yeah, and that's, I think, open to use in any normal cases. And JavaScript and Netscape and all that community started the thing that actually is called open source now. Because before that, not just open source, free software. Companies before that time were strongly against any free software, because with free software, you can't get money, right? That was the idea. But this theorem is a false statement. You can get money from free software. You can get money from open source. But at first, yes, Java started as a closed technology, something that would ease the sad life of C++ developers, to bring them automated memory management and all that. And now we know a lot of things about OpenJDK community, about the processes going there. And in JavaScript space, there's also some governance. There's a committee that defines standards, and now they are defined every year, which is convenient. Though a started is a set of enhancements, and mostly we see JavaScript supported by browsers or JavaScript engines, so-called, that implement not all the enhancements at once. So it's a different situation, not like in Java. But what's good, you can run newer versions of the standard using older browsers and all the JavaScript engines, because there's a project Babel that transpiles newer JavaScript to older JavaScript. Interesting technology. Now we have some similar possibilities with Java. I will mention them, but not really widely used. Well, Java started as a heavy enterprise technology. That was a breakthrough. When I first met Java in production, not as a university lectures course, right? It was a practical task. Hey, we have a proxy server implemented in Java. Please rewrite it in C. Okay. Is it a big program or not? Well, here's the code. Here's how it works. I'm like, okay. And then I started to think of, well, it's a multi-threaded program. It allocates some memory. And here in this Java program, there's no memory management. It all happens magically, and it works. And in the C++ program that does the same thing, you have to deal with multi-threaded memory management, and you immediately boom into some errors that crash your applications, but not always. So, and at the end, the performance was about the same, even at that time. That was impressive. So I started to think about changing my careers, and I finally did so. And started to learn Java and technologies that were also applied at that project, new projects that we participated at that time. One of them was JavaScript. So Web 2.0 just started to arise. All that Web 1.0 technologies, like writing EGBs, were at their power. So you see, well, that's so convenient to mix your Java code and your HTML code. But it doesn't look too convenient from user's perspective. And well, you can have some scripting without any server requests that validates something that does pretty styling at your web pages. Wow, that's cool. But JavaScript itself at that time was very, very simple, right? And it's still compatible with that early version. So basically, all functions are objects of the reverse. And you can still create all that nasty examples of quirky JavaScript code that blows your mind, just because it may be very unobvious, right? But it's still too convenient to use to abandon it. Well, so enterprise required some enterprise solutions. And the response was Corba in 1998. Kind of, yes, we can describe all the business objects with some cool business technology that existed for a long time after that. But that was extremely complex. But what was easy is having IDEs, right? Not appeared at that time yet. So we still could use our notepads, our simple text tools. I already mentioned, GSPs, not HBs yet, GSPs, to mix Java and HTML code. And the basic core technologies that are still widely used, such as Java beans, well, at least concept, right? Serialization was way ahead of its time, though there are still special appendixes in every big JVM feature talk or a note saying how it will work with serialization. Like the most recent one was a JVMLS about the current iteration of value types. So how this approach will work with serialization. Java had reflection from almost the very beginning. Reflection at runtime, very convenient. That later led to build many frameworks, like we'll see at the next page. But JavaScript from the very beginning, almost from the very beginning, had dynamic evaluation. It's sometimes if you start to implement a JavaScript engine, it may be a tricky feature or a buggy feature, but it's very convenient. So you can generate code right on your page and execute it right on the same page. Total mess. Very convenient to write code, not to read it. And you need something to execute that code, right? So the historical landmark here is the Internet Explorer version 5, which many developers had to support for many years, right? To get that basic JavaScript dialect that it was able to execute. Well, Microsoft did another good thing. They implemented XML support, which turned to be not XML support, but a real foundation for Ajax. The technology that we see daily and we use daily, it's just a foundation now. It all started with a custom component that you will access from a custom object, and it finally happened through ActiveX. Remember that? So you could drill and have more from your system as kind of platform-provided extensions. Yes, and Microsoft had their Java at that time, just like now, but now it's OpenJDK, and at that time that was a Java virtual machine implementation. And then JavaSpec, by 2000, year of 2000, debugging support has been added, which is really important. And I see now how non-trivial it is to write your debugging protocol for a new language, for a new runtime, and define it well enough so it would survive for many years. And it's easy to debug Java applications. If you think about it, you just do a very basic setup, right? Just open some ports, enable the agent, and you connect from your IDs or from Java debugging tool, text mode, and you can do that. I recently started native images debugging, and that technology is just in the beginning of this route. There are some design decisions, but they make it sometimes hard to debug your code if it's compiled as a native image. And if it's executed with a regular Java virtual machine, it's kind of easy. So the language itself, just like JavaScript, 24 years ago was plain simple, inconvenient, but brilliantly it worked. We had collections, though no generics yet. We had exceptions, so we were happy. Nothing happened without, final program crash. Of course, there are bugs in JVM, but if you have a crash in your business logic, you get all the stack traces, or you can catch the exception and handle it and proceed your execution. Well, in C++, at that time, there were also extensions to work with exceptions, but not that convenient. Well, not only JavaScript is a special beast that can behave unexpectedly. You can write a Java program that no one will understand, or it will work not as you expect it to work. So you can easily find some Java puzzlers. And there's a long, long history of making Java puzzlers. So every new Java feature produce some puzzlers, potentially. Well, you see what happened next. Java 1.6 was a modern technology, really modern technology, because we have clients who migrate now from 1.4 to 1.6. Not many of them, but it's still used and it's still supported. So you can get support for Java 6 or Java 7. So if you have 1.4 system, you know where to go. Well, surprisingly, essential features like regular expression support only appeared at that version. You see, here's XML support as well. Now, so it was time to think about performance. Assertions, not too widely used in production code nowadays, but I see them from time to time. And also, of course, all the necessary protocols for remoting, right? So that were essential things for Java as an enterprise technology to provide as a modern enterprise technology. XML was big at that time, 2002. At 2004, I participated in a project where everything was based on XML. Like XML was in that web pages. It's been sent all around, back and forth. SOAP. Data was stored in XML databases. There were special accelerators for XSLT transformations to transform your XML to a different XML using some XML language, XPath. Crazy. But it's, it's still the technology that we see daily. So I personally still mostly use Maven, not Gradle. And it's XML. I'm fine with that. Not so tough. And we needed some technology to wrap that XML on the client side, to deal with it in an effective way, to make a good user representation. So yes, Java EE appeared even later than XML support. Well, that makes sense in the end. Right, so first we define protocols, and then we define some nice higher layer protocols. And we had good building blocks, so we could take that XML, generate emails, and send them to customers using Java Mail. Wow. Other basics technologies are also 20 years old, like servlets, more than 20, right? Still, that's the foundation for your web server logic. HB is probably dead, but we still have the data part, right? Which turned to GPA and other technologies that work with data objects. And finally, something very important happened. Spring 1.0 was released. So it was invented 20 years ago, and it still drives Java forward. So the ecosystem without, IOC frameworks is impossible to imagine. So all that previous technologies, all that support for metadata, support for reflection, or dynamic stuff in Java, finally was shaped with a real framework. And I think Maven also appeared at the time first, and then Maven 1, then Maven 2. Maybe I had that in slides. Yes, and Spring 2.0 was quick. It was a long story for Spring 2.0, right? Spring 3 is still young, so it's a huge lineup of Spring 2 point something. And finally, in JavaScript, there was Ajax. A colleague of mine said, "Hey, see what I have here." And he showed me literally an IDE in browser. Wow, it works in JavaScript. But here's some more. We dynamically send all the XMLs we generate, and we receive them back without reloading the page. Wow. Is that possible? Yes, it works on this and that browser. Not everywhere, but it's like 95% of potential customers. So we can live with that. And later it was standardized. Like, well, we can do a lot of stuff with that. That entirely changed how people created their client-side applications. But internally, it was plain Ajax, like this. You get that XML/HTTP object to transfer any data, but it's called XML. And you create a callback, and you actually process what you do there, all single-threaded, etc. Well, just a year or so later, it became much easier because in a new project, someone else told me, "Hey, we don't need all that." But how? It's not possible. It's it's JavaScript. What happened here? And jQuery was invented. I'll show a code, and you'll see the difference. And at the same time, yes, you see down 1.6, and there are things like APIs for compiler, which I would say is the beginning of that long road of bringing more dynamic language features into Java. So it's a decade and a half old. It took some time, but at that time, Java already had a very sophisticated and effective virtual machine. So it was fast, it was effective. Yes, it already required warm-up, and people blame it to be slow, but not like JavaScript. So JavaScript engine creators decided, well, we need to conquer the internet, especially one of them decided to do so. And historically, they made it. But they started with improvements in their browser, releasing multiple iterations, multiple versions of their virtual machines. It started in 2008, and I remember first talks about how V8 internally optimizes JavaScript into machine code, and I was impressed, like, wow, I thought it's not possible. Though I studied compilers in university, but the things that they show, like, really in browser? Yes, why not? It's still a thing. It's an interpreted language, and you can JIT compile it, and you can get effective code, which will still be sandboxed. Very interesting. And if you have a virtual machine, you can execute JIT compiled code for some programming language. Well, it's a good idea to run it on server, right? Even if it's not type safe. So people started doing that. And the new ecosystem started to grow around Node.js, server-side JavaScript. And that gave a new impulse to the language community. So after a long break, a new standard appeared, which is ECMAScript 5. And even with, of course, some new things in it. Multi-line string literals, 2009 in JavaScript. Who remembers when they appeared in Java. I'll have it on slides, but not on this one. Yes, it's a new feature, right? Not in Java 8. Yes, and you see iterations for the Google's JavaScript engines went fast. And I promised you to show some jQuery. Here it is. Instead of manually searching parts of your XML or HTML document, trying to handle all the boilerplate, you can simply declare that, hey, framework, please find what's important. It's marked in my structure. And attach some business logic to it. And if you completely change everything, completely change your layout, even types of elements, they still will be found and the code will work. Was tremendous. And then after some time, Java 7 has been released. And in Java 7, we had more JVM features than before, right? There were some important language features like private resources, which develops now, and the idiom is reused by different language constructs. But it was more about some performance, about preparing foundation for big changes, like later string concat optimization, for example. That's what comes into my mind immediately. Or the JavaScript implementation based on invoke dynamic. At the same time, almost the same time, the effectiveness of JavaScript interpreters and JIT compilers was questionable. But people still desired to have faster code on their pages, and specifically people who wanted to conquer the internet, right, to provide web services for end users as big platforms. So SMJS was created. And SMJS was a way to give some hints to your JavaScript JIT compiler, so it would conclude final types of some parts of your program, of your variables. Like here you see, if we have a shortcut where we pipe with 0, for example, compiler knows from this very place that the type of this spot is integer. So it's easy to prove it elsewhere in a program where this thing is used. But it's not too convenient to write such code, right? But this was just the first trial saying, hey, this helps. Maybe something useful can grow from this technology. Meanwhile, besides of the code effectiveness and code effectiveness related to typed code, typed code has other good sides. Like if you use types and statical typing in your code, you're more safe from errors. And the idea led to a new language called TypeScript. That's actually a special language that's somehow mostly compatible with JavaScript and compiles into JavaScript. But we don't need to write JavaScript in a special way to give types for compilers. We write in a different language, which is very close to JavaScript, but just it has types for developers. And that's the process that nowadays happens with Python, right? If you write in Python without types, probably you're not an enterprise developer in Python. Well. And finally, in 2014, our favorite and most famous Java released. was made? Java 8, which will be supported at least 2031. Yes, keeps changing. Follow the updates. Yes, and Java 8 had many changes in both virtual machine and the language. Of course, standard libraries as well. You see more thoughts about concurrency. Like what else sophisticated can be added to all the concurrency primitives to ease higher utilization of your hardware. Because at that time, having multi-core machines started to be typical not only for server side, but also for a client side, even for embedded. That was a challenge, how to utilize that hardware in an effective way. That's why how completable future appeared, the core pool, stream API, right? Because it's a way to write short code that effectively can be executed in parallel. And Java had a JavaScript engine in it. And still many people ask about that engine. Like, hey, what about Nashorn? What about having GS right in our Java distribution? And of course, it had lambdas. That really changed the way we program in the language. And that was one of huge moves that I remember very well. Well, meanwhile, other languages had lambdas, and they had them before Java. Well, way before Java. It was a well-known concept, and it was a big question like, hey, are you going to have lambdas finally or not? I would say the biggest pressure was from C# side, because they had it from years before. Yes, and you see JavaScript spec started to evolve more rapidly. Like in 2015, there were finally constants, well, so-called constants, right? The final values in JavaScript. Some sophisticated assignments, lambdas, later than in Java, surprisingly later. Iterators, generators, promises. Well, there's no multi-threading, but there are promises. So you can still define logic that will be executed sometimes or somehow later after the main page code will finish its execution. And JavaScript got classes. And now it's a common practice. You have all that object-oriented code, because it was a truly object-oriented language before that. Because you had objects, not classes. You also had prototypes that were also objects. You had functions, and everything was a function, and also an object, and also an array, and also a string, and also an integer. Yes, but now officially inspect as a great syntactic sugar on top of all that. Now we have classes in JavaScript, and now we have inheritance. And finally, standard library specified in that spec got map class. That's a huge success. Imagine all the history of Java collections, and finally JavaScript gets a map class in 2015. Nobody needed that. Yeah, that's the evolution of mindset, I would say. And the code became, well, even simple code is not that easy to understand, right? What happens here? So we have sophisticated things that we can do with arrays. We can declare objects in a very simple way, right? And by the way, do we already have JSON in the timeline? Maybe I missed it, but yeah. So now JSON wasn't there from the very beginning. That was a very important step to have it. So, and as soon as it appeared, it immediately replaced XML. Yeah, I think that's the time of jQuery. JSON started to be popular and started to overtake XML in all the communications, and that's the main thing that we use now. We use, if it's not specifically implemented as REST, a pass JSON, and well, it's done. Yes, and console and other nice things in JavaScript. You see that TypeScript became popular as well. So just in a few years, another version has been released. And versions of TypeScript started to appear quicker. But still, the ECMAScript is the foundation. So you have to be JavaScript, mostly JavaScript compatible. But TypeScript introduced an important concept of null safety. And it also introduced generics, not JavaScript, but TypeScript, right? Because there are types and everything is based on types. So you need generics. You can't just assign a thing, right? So just like in Java, collections without generics were a pain. If you wouldn't have to conclude the exact type, that wouldn't be a problem, but we have to know the exact type at Java compilation time. So TypeScript got it. And we get Java 9 that started to its way to clean design, to greater features, safety, getting rid of all the unsafe internals and providing better alternatives to build high performance frameworks. At the same time, you see, instead of awesome.js, we had WASM, which is WebAssembly, which still continues being a thing now. It's the same idea of having a bytecode for your language. And it's 2017, right? And Java had it from the very beginning, and Pascal had it. That's kind of right move, and academia knows how to deal with bytecode. What nice could be done, you can
We do it right.
verification. Yes, and to do it right. But yes, you can transform your JavaScript into some effective bytecode, but you also can write an interpreter for Java language in that bytecode, or simply in JavaScript, but to run it faster, you need to compile it to something easier for JIT compiler for your JavaScript engine. And where are now that implementations? So we have JavaScript implementations in Java, and we have Java implementations in JavaScript. That's funny. Well, Java sometimes started its LTS journey, right? New release train. Finally, it's much more convenient to determine what's the next important release, or to wait for some feature to be finally integrated, because the conflicts became smaller between features. Java 11 introduced concepts like things essential for other languages. To run your Java program with your Java development kit or your Java runtime engine. Just take a Java source code and run it. It also introduced more advanced means of communication. Like here, HTTP client and TLS are listed, right? Very important for microservices. So you could easily build all your framework code or your application code right on the foundation of your standard library. And NASCode has been deprecated. Well, no more JavaScript. Yes, and even before Nashorn, there was Reno engine implemented in Java, not using Invoke Dynamic, but just pure implementations. And you can run Java programs as executables, just saying, hey, please execute this script with Java on your system, like user JVM bin Java or something. Just find it and run this Java source code. So Java started being a script, but not JavaScript, because JavaScript got it later, much later. Yeah, and I would say that's a new history right now, right? So it's Java 11 and TypeScript 3. You see how JavaScript started matching many features we are used to, like regular expression support. Wow. In many languages, I just focused on regular expressions. Who remembers? Like Perl. Yes. And then got async await and more advanced promises. And a very useful feature, I really would like to see it in Java, trailing commas. Because we use web reviews, we use version control systems. And if you change the tail of your array, it's better to have an option to leave the comma, just to have smaller lines in your div. And in modern age, we now also have GraalVM technology that has that polyglot compilation thing that turns your interpreter into a JIT compiler and supports many languages, including JavaScript. So you can effectively combine Java and JavaScript code within the same virtual machine, having calls in both directions. And it has pretty good support of ECMAScript 6, which is quite new. I'm not sure, maybe even more advanced support for now, but at that time it was ECMAScript 6. And it supports WASM, so it's easier to plug into something compiled into WASM, which can be anything, like a Java virtual machine written, well, in TypeScript. Why not? And you see a programming in Java where we still had to write too many things by hand or to read them because our IDE generated write code. Those things started to be simpler. Switch expressions in all of their ways, switch expressions, instance of different statements. That's a story started in 2019 and it's still ongoing route of optimizations in the language to let developers write less code. You see, Java's, it's more convenient to write foreign code in Java if we use text blocks. So at the same time, we had interesting technologies of combining different languages and means to write code snippets in different languages inside our Java sources. So I mentioned that, yes, switch expressions, they developed for many years, and it's still an ongoing process. And yes, Nashorn removal, JDK 15. So you see, it first was deprecated, then people still continued using it. Finally, it has been removed. Well, what about enterprise features in JavaScript? In 2020, it got support for banking systems. Big int. No more need for Java. You can use map and you can use big int. You're all set in JavaScript. And you can use it on the server side and you can get JIT compilation. That's nice. Well, in the language, you have some concept of nullability, not real, type system, but the convenient ways to ensure and have default value if the checked value is null. And JavaScript got special operator for that. It's called nullish-Carlesian operator. And you know other languages like Kotlin, for example, where the concept of nullable and not nullable types is very important and very helpful for developers. And just recently, there's a chapter draft, I think, about nullability for types in Java. And it's by itself, it's a very cool feature. So you can write type-safe code and the compiler will check everything for you, not using any custom annotations, just using a thing built into the language. But it was more surprising to me what I heard on the JVMLS. So this feature turned out to be a key for Valhalla implementation. Like just saying, hey, some fields or objects are they're not nullable, that's it. So we for sure know how it should work. If they're not nullable, they don't have to have a default value. And it's a solution to many problems. And the second second bit of the key for that problem, for the solution for the problem, is having that early statements in constructors. So before calling super constructor, there may be some statements, and for value types, it's currently proposed to have some mandatory statements before super constructor calls. So here are language features that make the language nicer and more convenient for developers also help virtual machines to have minimal and effective implementations for performance features. Well, I mentioned GraalVM. I'm not sure how aware you are of the technology, but it's a different virtual machine that can work dynamically, or another virtual machine that works in a binary compiled ahead of time from your Java sources or Kotlin sources or whatever bytecode you have, and allows you to have big performance from the start, though probably not all the performance of your dynamic compiler, but in many cases, that's the cloud native way that can solve a warm-up problem. And it allows you to combine different languages, combine different bytecodes, Java bytecode, WASM, LLVM bitcode, all supported by Graal. And itself, it's written in Java. So it started as a very interesting scientific experiment, having more meta-circle implementation for Java, but still production grade. And you see, unlike, for example, Nashorn, it's easy to use JavaScript from your Java code if you use GraalVM. So you can really reuse some code if you need to. Like for me, typical examples are like validation and libraries for some analysis or generating images, so things that are historically implemented, not in Java. Well, we saw the Java 11 and the versions till Java 15, but even just 3 years ago, Java 16 has been released. And it had the development of that idea of better and shorter code, where you know the type of your variable early in your program, so you can conclude and reuse it without typecasts and other unnecessary boilerplate. So type system evolves. Like we got sealed classes, path to algebraical data types. And ECMAScript defined weak references at the time. So you can create a map and put weak references to big integers there. also good. Though there's finalization registry, and I'm afraid every time where I read word finalization, because we all try to forget that it still exists in Java. That's that will probably the longest deprecation story in history. Well, though it has been deprecated for removal in Java only in JDK 18, after the finalization registry has been introduced in JavaScript. It's a funny story. Yeah, and you see in the type system, Java got records and record patterns, which is also very convenient. So to simplify all the programming, you don't have to define all your hash code and equals. You don't have to write all getters and setters, and you will have values from your records easily by deconstructing them. And JavaScript, it already had classes, you remember, right? JavaScript got private fields. Though as easily accessible as, you know, private fields in Java, we still have all that unsafe tricks to make the field accessible, even if it's private and final. So in JavaScript, it's even more of that. It's a syntactic sugar, but it's convenient. It's just a hashback modifier. Surprisingly, we turned everything into a Polish notation as programmers. Yes, and it has in operator. And yes, so improvements that really make JavaScript code sometimes look like Java code, or I think other relative languages. So you can have static data, you can have private static fields, like here. We have constructors, destructors, you see. But Java already got records. I made a small update into that slide deck. We'll see it later. So I mentioned that regular expressions were extremely important in Java, and we actively use them. But even that core technology still evolves, right? Like named groups. Surprisingly, we didn't have them till Java 20. That sounds scary. Yes, and very cool feature, pattern matching for each of those. I already mentioned record patterns. So yeah, it happened later, JDK 20. And JavaScript started to work with essential algorithmic things that we are used to have in Java, like custom sorting for arrays, right? Comparators. So you can create a lambda and you can pass it for comparison for your sorting algorithm, which is, well, sounds trivial in Java world. But in JavaScript, yeah, the developers create more and more code that continues to last for years, not just one-time code that will be thrown away next year. Probably the JavaScript legacy is changing and it grows. So things like that are really necessary. And you see, it also got shebang support. Just like being a normal language that you can execute at your workstation and use as a script, JavaScript script. Though my experience with installing different JavaScript engines is really bad. So anyone who tried to install Node.js in a few different ways would agree, I guess, and to use all the NPM registries. Well, after you've done it, it works, but if you need to update it, it also becomes tricky. Maybe it should be simplified somehow. Oh, that's a plugin of a different slide deck. You probably saw it, but it's about Java 21 and what we have got in the most recent LTS release. And LTS releases are LTS because someone does the S. You know, that's why I list our products here.
He does it for an LT.
Yes, yes. And we do it for LT, exactly. So you see there are many jobs delivered specifically in Java 21, but I'll only highlight some of them. So of course, the big JVM feature is virtual threads. Well, it's the same continuation of in solving the same problem of underutilization of modern processors with many CPU cores. Of course, you can have it fully utilized if you run, asynchronous code. But we can maybe easily run asynchronous code, but we can't debug asynchronous code. Even though they have debuggers, we have IDEs, but having the context of your asynchronous call is impossible. So you have to imagine what really happened in some time in the past before your asynchronous call actually was triggered. So the implementation is notable because there are different virtual machines, and a big stake of this implementation lays in the standard library, in Java code, not in the JVM. And you see there are modern features like JSON thread dumps, right? So it's JavaScript objects created from Java virtual machine. So you get information easily parsable for tools written in different languages like JavaScript, for example. So there are tools in Linux where you can easily navigate JavaScript objects like JQ, so you can create queries in your command line. So these changes just follow real industry practices. And Java threads, of course, have their quirks. Historically, they have been resolved, and most of them have been resolved by now. So in Java 23, we'll see even better implementation of virtual threads. Meanwhile, they were adopted by frameworks, by web servers, so we can easily turn them on and use them if we have new enough code, new enough libraries to migrate to Java 21 and to enable them. But there are pitfalls. Like recent story from my friend, he said, well, I wanted to you promised me better performance. I enabled virtual threads, and I got new crashes. Okay, tell me what happened. So he just flipped the thread pool definition in some of his applications. And eventually, before that, he had not only underutilization of resources, but he also had a kind of natural back pressure. When he had starvation of real threads because they were busy, but actually not busy because they were waiting for responses from the database, and the thread pool was limited. And user just got the user timeouts. They had nothing performed for them because their accepted thread was not in action. Instead of that, he got some code being executed because he always had a resource to execute his code before the database request appeared. Right? If you have other endpoints that don't have to go to the database, it's good for you. So you can execute them, and all the things waiting for the database, just wait, and then they return their results, and you have fully utilized CPU. But it turned out that in his example, in his case, and in many similar cases, all the requests go to the database. So there's no point in switching the thread pool, at least in a simple way. So you will have to define two pools. You'll have to define some limitations for your accepted connections to keep the behavior reasonable, and still have that limitations for going to your database. So that's challenging, but it's worth trying. And it's easy to have a virtual thread in wild. Just use a different factory method and get a different implementation. Or yeah.
Say that
Well,
again?
when is beneficial to use virtual threads?
When is it advantageous to use virtual threads?
Because it really solves you the complexity of context switching, the overhead of having many threads. So you don't need 1 megabyte stack for every one of them. You just need a tiny amount of space in your Java heap. So it's cheap. You can have millions of threads. But that doesn't necessarily mean that you will have better performance than having just 10 of them.
My question was, is there a time when it's better not to use virtual threads?
When
Use
to not.
conventional threads?
Yes, in such cases where it breaks, really breaks expectations that users have from your application. Like this, you have some natural back pressure, and this service level agreement is broken here.
If you have too many of them, won't you have like some sort of a problem with your memory, right? I mean, there's just too many threads potentially, too many objects.
Yes, you can. But well, any rewrite of a program is painful, right? So we don't like to change our code, except it's a little change that gives us a lot for free.
I got the thing. In recent years, in the JavaScript side with React, there's been a lot of tools that have come out for state management. And is there anything like that instead of this virtual thread thing? Is there any state management functionality considered, or for the asynchronous problem where you're waiting for things?
Yes, there's now in Java it's more complicated because Java has real multi-threading, right? It's a very well-developed one. So there's now structural concurrency where we can control threads execution and gathering some results. And there are scope values that define something only existing in the scope prepared for that code that you have defined. That's probably the analog of this.
That would be a good project for Bellsoft to consider.
Yes. State management, I like it. Yeah. So yeah, another big virtual machine enhancement is generational ZGC. So initially there was a ZGC implementation as experimental garbage collector. Later it transformed into just regular non-experimental but non-generational ZGC. And in Java 1, it's possible to enable generational ZGC as an option. And with that, you have same very low pauses, very short pauses. I really observed sub-millisecond pauses on heaps larger than 100 gigabytes for quite oldish applications, but we just switched to using ZGC. And with generational ZGC, you don't need that much heap to have very short pauses, because it quickly sweeps all your young generation, and you only rarely need to collect your old generation. Obviously, that's the idea of all generational garbage collectors. And it's easy to enable. Just you can try that and scale your application vertically. That's to me a first move before trying to scale the application horizontally, having more replicas, trying to deal with a larger fleet of copies. Try something in the virtual machine. Try larger heap, maybe a different hardware, larger port. That's convenient. Surprisingly, collections API is still being tuned. So since Java 21, we have a different collections API. You see those green rectangles. So we now have sequenced collections. But having them, well, makes the structure more relevant, and it allows to use additional methods, like to find the reverse collections, or to get elements defined by the order, like first and last. Makes sense only if you have some sequence. Key encapsulation is also a tricky task when we exchange data with remote parties. So in Java 21, there's now a standard way of getting some key using your provided encryption with your public key. And I already mentioned pattern matching for switch, and now it works for record patterns. So yeah, we can write very, very short code. I unexpectedly started using records in some code that that didn't need, you know, they didn't need to get rid of equals of or and hash code, just because it's convenient to write all that, to define objects, to assign them in a short way, and to write pattern matching that deconstructs all the internals of records, and you immediately see all the types here, and you apply some actions to them. So yes, we can now write that short classless code and to execute it without JavaC invocation. So it's been around for almost a year, but it's not the end of the story. That's a bit older slide. We still have some time. Let's look at the latest changes. So we have Java 22 and Java 23. And some of the things probably were mentioned today. And we have ECMAScript of this year. And then ECMAScript has a nice chaining support for calling lambdas on your data or function results. There's datetime, temporal API, even more enterprise JavaScript. There are also records and tuples. By the way, I really like the way tuples are defined here. It could be possible in Java. It's just records are immutable objects, and tuples are immutable arrays. That's it. Well, it's simpler in JavaScript because, you know, there are no types. So array naturally can contain different things. In Java, it also, well, it can contain object, but it's not a good practice to put different objects there. And it's not clear how to define such a thing, but just saying here is an immutable array, which is a tuple, it's very convenient. And there are now annotations. So you can annotate that constructors or methods in your classes in JavaScript, or like you can already use static private fields. Very convenient. And we discussed ZGC. So generational mode is the default mode, will be the default mode in Java 23. Patterns would allow primitive types. So this part was missing right? It's convenient. And just like in other languages, it would be possible to import modules, not individual classes or wildcards or whatever. So we have modules, but well, who uses modules? Yeah, JDK team. So that's the current development, and I really like it. We have more convenient Java, more convenient JavaScript. And we have some materials in our blog, so you can try and visit it and write some articles. And yeah, I think that's the most of the material I wanted to present. Questions?
I have a question. I've heard two things about GraalVM. One is that there is a virtual machine of sorts
Yes.
there, and the other is that there's no virtual machine, that it's right on the metal. Can you settle the argument?
There is a virtual machine. So if we run GraalVM with Graal as a JIT, it's basically a hotspot virtual machine, just with a different JIT. It's not entirely true, but essentially it is so. And if we compile a native image, there's a special runtime and a special virtual machine called Substrate VM. So there's implementation. There are garbage collectors implemented, like we have implemented parallel GC for that virtual machine. So you have to provide all the means that JVM must provide to a Java program. You allocate memory, you collect your garbage, you provide the means for native calls, and all basic facilities. So it's a JVM responsibility.
So it looks like a native executable, but it's not quite.
It is a native executable, but with the runtime.
Okay.
Just
all right.
like,
okay.
yeah, your regular JVM is also a native executable. And it takes your bytecode as a data.
Gotcha. Thank you. Other questions?
Yeah.
Where? There it is.
And this is kind of a political question, so I'll understand if you. So I'll understand if you do not want to answer this one officially. Where do you guys fall in the whole Oracle versus Google lawsuit and issues as far as Java and the JDK and what Oracle has been doing to developers, particularly in terms of trying to copyright APIs?
Which APIs?
All of them.
Well, it goes well so far in OpenJDK. So what's the exact problem you see as the most dangerous here?
Well, so Oracle is suing Google and saying that for every Android phone, because it runs Java, that they can Oracle can extract money.
Yes, but
Still going on?
Well,
I think
that's some new iteration.
Yes, that's what they're starting to switch over to Kotlin as a result of that and getting away from
Well,
Java.
I can't comment the legal part, but I think for us, it's like, okay, some company pays some other company or just doesn't pay a certain amount of money, which is billions, but still.
But we can count on the OpenJDK even if.
Yes,
Even
definitely.
if, Oracle
I'm not sure if we
decides-
can count on Android, but on OpenJDK, yes.
I don't think there's been anything new on that.
Well, to be able to hear you, Scott.
I don't think there's been anything new on that case for years now. I think it was settled a few years ago. They Oracle won. Oracle lost, if I remember.
Right. So, show this line again.
I don't
Yeah,
know.
you can easily contact me.
Okay, here, where are we? One more
Yeah,
question.
please go ahead.
Here we go. Wait. Here.
The virtual threads, just so I understand, what we're talking about is basically an abstraction that has less context switching, less overhead, but you still have too many threads. You still have too many threads. It's not a magic bullet.
Well, I heard a story where people did saw limitations related to a number of virtual threads. That was a very special case. it's really hard to see that in a while. So they had strong SLAs for their database responses, and they have associated contacts kept in virtual threads, and they created a lot of them, really millions. Surprisingly, they switched to the technology. But they ended up with simple solutions. So trivial, you still have to somehow limit your thread pool, even if it has virtual threads. And they pulled some other things too. That's it. So in the end of the day, they had their profits from using the technology.
Huh? Mike, you're gonna take over here?
Oh, thank you. Yeah, if you need it.
There you go.
So I didn't think of it at the time. I should have added some things about nullability in the what's new section earlier. But there are two news items on InfoQ. They're still on the main page. One was published yesterday, one today. Jay specifies this new group. It's a collaboration of a number of folks. I think Google's one of them, or but I'm trying to remember. But so Ben Evans, who's a news editor at InfoQ, wrote these up. And so, yeah, check those out if you're interested. JSpecify has 4 annotations. One's at nullable, one's, I don't know, I forget at the moment. But, and then, yeah, that's the JEP draft, 830-3099. So I'm sure it'll become a candidate. No, I did. I looked it up again. So yeah.
Easy to remember.
So yeah, in any event, yeah. So check those out. I presume that'll become a candidate at some point with its new JEP number. But so I can switch back to the
Browser?
yeah. So oh yeah, that one. Yeah.
You have to go live stream.
Oh.
Or share screen.
Oh, okay.
Let's share the screen.
I got you.
Oops. Oh, I see. Let's share the desktop.
Nope, there we go. I think it's there. Perfect. Great. Thank you. So first of all, yeah, thank you for that trip down memory lane. I mean, a lot of us have been around a while to have experienced some of this stuff. I remember Ajax and, thinking it was a great thing, but then of course, you lose interest. Yeah, you go on to other things, but yeah, so that was fun. I really appreciated that. Upcoming events, a couple, shameless self-promotions. Tomorrow, if anybody's interested, I'm presenting at the Jakarta Tech Talks, a developer's guide to Jakarta EE11. This follows up from my earlier presentation on Jakarta EE11 going beyond the era of Java EE. So check that out. It's on Meetup under Jakarta Tech Talks. So you can join. It's at 10 o'clock tomorrow morning, our time. And upcoming events, Dev2 Next is being run by Venkat Subramaniam. That is on Monday through Thursday, September 30th through October 3rd. It's in Lone Tree, Colorado. The Open Community Experience, formerly known as EclipseCon, is going on in late October in Germany. So if you don't have your passports updated and you're interested in seeing Deutschland, you can definitely do that. QCon San Francisco is in late November, a week before Thanksgiving. At the Hyatt Regency there. I'll be there again, serving as a dedicated reporter and some more shameless self-promotion. I was asked to give a workshop, which I was quite surprised and flattered to have been asked to do that. So I'm doing a hands-on workshop on, a basic Jakarta EE app, and then add things like validation, security, all those, some of the other specs that are part of Jakarta EE. So that's on Thursday, November 21st. So yeah, it should be fun. I have my work cut out for me, but this is why I retired in the first place, so I can do all this stuff. And then upcoming events, for us. Next week, Rustam Mamandarov will be here, present Java on Google Cloud, the enterprise, the serverless, and the native. And then Marcus Hellberg will be here on September 10th, talking about AI. And then we have Scott Strohs talking about using MySQL document store, which is similar to MongoDB. And so it's MySQL's version of a NoSQL database. And then Rajiv Shah, who was in New York back in June, is going to discuss unified real-time data processing architecture pattern for multi-dimension data problems. In December, we have Amal Dote to discuss digital signatures decoded. And Scott, you need to give me a title so I can take that off of there. This Down Home Country Coding is the name of a website, right? Yes, he's waving high over there. Okay. Anyway, yeah, him and possibly Gene Boyarsky are going to be discussing how to pass the Java 21 certification, right? Well, will you send me send me a title, will you? And then, and normally do some of the friends of the Garden State Jug. I didn't get a chance to look at who was doing what, but so we'll skip that for now. And then, by the way, if you saw Barry and I going back and forth, we had a major snafu tonight. That's live streaming wise. And
We'll get it fixed.
we'll get it fixed, yes. And so basically what happened was on YouTube Studio, we somehow had
Steve,
both.
Mike,
What?
mum's the word.
Okay, mum's the
Don't
word, yeah.
advertise.
I know. Okay,
We don't need behind the scenes.
yeah, that's fine. Well, we'll fix that up.
Everything was fine tonight.
Okay,
Yeah,
everything, yes,
worked.
okay. I'm getting the hook here, I think.
That's right, that's right.
So, anyway, so we hope to see you here next week, hopefully back at the Dorothy Young Center for the Arts. I won't be here. I'll be sitting in Florida. So, so Barry, of course, will be here, and hopefully some of the other people on the leadership team like Scott. So anyway, thank you very much, Dimitri. Thank you. We appreciate you coming out after spending at least a week in New York, and but we'll see you next week.